This video is about drawing conclusions based on given information. So in the first one, we already have a given statement that BD is an angle bisector. So this ray is an angle bisector of our larger angle ABC, and our reason is that it's given to us. So we need to make a conclusion based on that information. Well, based on that information, if it's an angle bisector, then it's cutting the angle in half, which means that angle 1 is congruent to angle 2. And the reason is we have to explain what an angle bisector does. So we would say an angle bisector cuts an angle into two congruent parts. In the next one, we are given the diagram, So based on the diagram, we have to make some kind of conclusion. Well, we know that angle 1 and angle 2 are vertical angles and that vertical angles are congruent. So our statement would be angle 1 is congruent to angle 2. And then our reason is that vertical angles are congruent. Now the next couple, we're going to be given a statement, but we have to start out the proof. So ray RL is perpendicular to segment TS. So our first statement always starts with the given. So we need to write this down that RL is perpendicular to TS. Remember that our reason to start is always given. Now, we have to think about what does a perpendicular line do? Well, a perpendicular line makes right angles. So where L, at point L, it's intersecting and forming two right angles. So we can say in our next statement that RLT and RLS are right angles, or we can even number the angles, and we can say angle 1 and angle 2 are right angles. The reason then is we have to explain why do we know that they're right angles? We know that perpendicular lines form right angles. Now, there's one more thing we can do. Knowing that they're right angles, we know that they're both 90 degrees. If they have the same measure, we know that angles can be congruent. So then we would say that angle 1 is congruent to angle 2. And our reason would be that right angles have the same measure and are congruent. So remember, in order for angles to be congruent, they have the same measure, and right angles always have the same measure because they're 90 degrees. The next one, M is the midpoint of AB. So we need to start by writing that as our given statement. So one, we would say that M is midpoint of AB, and our reason is that that's given to us. Remember that a midpoint is halfway between the two endpoints. So if M is halfway between, that means it's bisecting, and AM is congruent to MB. So statement 2, AM is congruent to MB. And the reason then is that a segment bisector cuts an angle or cuts a segment into two congruent parts. Next, we're given that BC is parallel to AG. So we would say BC is parallel to AG. The reason is that that's given to us. Now, if we know we have parallel lines, AC is going to act as a transversal, which means that the angles in the corner, which we can again call angle 1 and angle 2, have to be congruent because those are alternate interior angles. So we would say angle 1 is congruent to angle 2, and our reason, if lines are parallel, then alternate interior angles are congruent. Our last limit, BL, is the perpendicular bisector of UE. So we're going to start by saying our given statement. So we say BL is perpendicular bisector of UE. Remember, we always start with a given statement. Now, if it's a perpendicular bisector, there's two pieces here. So first we're going to deal with perpendicular. Remember from before that perpendicular forms right angles? So we have two right angles here, angle 1 and angle 2. So our first statement would be angle 1 and angle 2 are right angles. And our reason is that perpendicular lines form right angles. Once we know that the angles are right angles, we can also then say that they are congruent. So angle 1 is congruent to angle 2. And our reason is that right angles have the same measure and are congruent. So this took care of our perpendicular part. We also need to take care of the bisector. So remember the bisector is talking about the segment in this case, and that if BL is the bisector, it's cutting this segment into two congruent parts. So we would say that UL is congruent to LE. And our reason then is that a segment bisector cuts a segment into two congruent parts.